So we're going to talk very briefly about inequalities. So first of all, inequalities, basically, right, if you just look at the word, inequalities, it means not equal. So it's everything else. So it's these. Do you remember these? So this, you would, as you read it from left to right, you would read it less than, greater than, this one's less than or equal to, greater than or equal to, and then what's this last one? You may not know this last one. Yeah, not equal to. It's just an equal sign with a slash through it, which basically just means not equal to. Okay, so you've been using these symbols for a long time, hopefully correctly. So, for example, if I ask you to compare the numbers 3 and 5, well, 3 is less than 5, so you would put a symbol like that in there. Okay? Maybe in elementary school you learn that you turn the inequality sign into a Pac-Man or an alligator or whatever you want. I don't really care. And the thing is always going to eat the bigger number. So if I have my Pac-Man here, he's going to eat the bigger number. So when things go into negative land, when I'm comparing -3 and -5, what happens? What happens when the numbers both go negative? Who's bigger now? Yeah, remember, on the number line, right, if I have 0 here, as you get more and more further down the right-hand side, the numbers get bigger, further you go. The further away from 0 they go on the left-hand side, they get smaller. So for that reason, -3 is actually bigger than -5, right? Things switch over in negative land, right? Because -3 would be here, -5 would be here, so -5 is actually smaller than -3. Okay, so if you have, let's say I want a variable to be greater than or less than some number. So let's just say I had, I don't know, I want to represent all the numbers greater than 5. I can write it just like that. That notation right there just means all the numbers greater than 5. Does it include 5? No, because 5 is not greater than 5. Okay, so this represents all the numbers greater than 5. We can represent this on a number line. Okay, so if I wanted to put this on a number line, I don't need you to give me every single number under the whole, I don't know, on the whole number line. Obviously I need a 5 because that's the 5, that's the one that's important. Well, not there yet. Hold on.
Is that what it is though?
Maybe. Well, we gotta talk about it. So I probably have a 0, 1, 2, 3, 4, 5. Okay, that's fine. If the number is 29 though, you don't have to start at 0 and go all the way up to 29. Just make 29 the middle of your graph. Doesn't matter. So now, if I wanted to show all the numbers that are greater than 5, here's my problem. We're going to put a dot at 5, but I can't include 5 because 5 is not part of my answer. So do you guys, bless you, do you remember, bless you, do you remember what you do to show that I want all the numbers bigger than 5, but I don't want to include 5 itself? Anybody remember how you do that on the number line with the graph? Gianna? You are right. Which do you think it is? If you had to guess. You would be wrong. You're going to have an open circle, yeah. So if I don't want to include the number that I'm talking about, which I don't here because I don't want to include 5 itself, I put an open dot at 5. And then you're going to shade over all the numbers that are in fact greater than 5. So they're all this way. So I kind of like to make a thick line. And then you want to put an arrow at the end. So this is another way to represent in a graph that same thing. All the numbers greater than 5. I put an open dot at 5 and I shade to the right. Everything you shade over, you're saying is an answer to this. Right? I shade over the number 6. Isn't 6 greater than 5? Yes, it is. I shade over 7. Isn't 7 greater than 5? Hi, thanks. Wait. You need one of these and one of these. Okay, so that's how I can graph all the numbers greater than 5, just like that. Okay, let's try another one. Say I want to do all the numbers less than or equal to -2. Okay, so I'm going to give myself a number line. 0, -1, -2, maybe -3, that's fine. But this time, is -2 an answer? Is -2 less than or equal to -2? Yes, it is, because now you have the or equal to part. So it can either be less than or it can be equal to. And -2 is certainly equal to -2. So this time I want to include -2 as part of my answer. So you use a closed circle at -2. All right, and now where do I shade? Well, how would you read this out loud?
X is greater than or equal to. Oh, it's less than or equal to.
Yeah, but it's a big difference, right? Remember, the Pac-Man's eating the -2, so that's the bigger number. So this one's smaller. X is less than or equal to -2. So where would I shade? Where are the numbers less than -2?
-2, -3 to the right.
Yeah, I would shade to the right. Does that make sense, everybody? Yeah? And everything you shade over, you're saying is a solution. So if I plug in -3, is -3 less than or equal to -2? Yes, it is, so I know I shaded the right way. Okay? Let me try and trick you. You ready? Okay. What if I did something like this? And I asked you to graph that. Go ahead and try it. Put what you think it would look like. Okay, you put something down? So, let's just recap. How do I know if it's an open circle or a closed circle?
If it's the greater than or equal to or less than or equal to, it's going to be a closed circle.
Yeah, if it has the bar underneath it. So if it's one of those two, you're always going to use a closed circle. The way I don't know, I remember it this way. It takes more ink to make these because I have to add the bar, so it takes more ink to close in the circle. This one's just going to be these two. Okay, so make sure that you remember. If it's... Oh, we'll talk about that one separately. So if it doesn't have the bar underneath it, it's open. If it does have the bar under it, it's closed. Okay, so hopefully you remembered on this one, okay, this one has the bar underneath it. I'm going to put a closed dot at 3. But now you got to worry about the shading. So I tried to trick you on this one. If you read this out loud, right, it would read 3 is greater than or equal to x. That's really weird when I go to graph it. It like feels wrong. So here's a handy hint. You can always read inequalities backwards if you want to. I always like the variable to be the first thing that I say, not the number. Okay, so if I just do this all backwards, so if I literally, like, imagine like a mirror's here and I'm going to flip it over. X, see how the arrow's pointing to the X? The arrow's still going to point to the X, it's just going to go this way. And then the 3. Like that. Do they mean the same thing? Yes, as long as you make sure that you write it the same way. X, the arrow's pointing at the X, the arrow's still pointing at the X, and then I have the 3. So these two things are exactly the same, but it is so much easier for us to graph when the variable comes first. In fact, I'll show you, do you guys know the little sneaky trick if the variable's first? Do you know it? Does anybody know it? Danielle?
The greater than signs of the arrow.
Yes. If you have the variable first, the inequality sign shows you which way to graph. So this one gets graphed this way, and then the arrowhead matches. See how it matches? See that? That'll always be true as long as your variable comes first, right? Look at the first one we did. X was greater than 5. Look how my arrowhead and the arrowhead of the inequality symbol match. So that's always true, even on this one, as long as you have the variable written first. Okay? So in my opinion, it's worth the time to rewrite it like this. Do you have to? No. Mathematically, they're the same thing, but it's so hard for us to wrap our brains around this when you're trying to graph it. Unless you just read it in your head backwards. X is less than or equal to 3. Means the same thing as 3 is greater than or equal to X. You can read it either way. So you might as well read it the easier way. Does this all make sense? Yeah? So especially if the variable is not first, it might be worth plugging in a number. So for example, I shaded over 1. So 1 should be an answer. Is this true? Is 3 greater than or equal to 1? Yeah. It's also true on the other side if you flip it over. Is 1 less than or equal to 3? Yes. It's the same thing. It's just a lot easier to graph if you have the variable first. And if you know the special cool little trick. So, that is handy. So you try this one. Oh, graph for me this. Do you guys remember dealing with these at some point?
Yeah.
Okay. Has anyone never seen an inequality before, ever in your whole life? All right, good. So, maybe you took a moment to rewrite this. If I rewrite it with the variable coming first, make sure it looks like that. Right? The arrow's pointing at the X. The arrow is still pointing at the X, so I didn't mess anything up. So I like graphing this a lot better. So what kind of a dot am I going to put at 0? Open or closed? Open. And then I would shade to the left. So look at your graph and see if it matches my graph. Does it? So again, do you have to rewrite it? No. But I think it's way easier to. But I'm not like going to mark you wrong if you didn't. But I will mark you wrong if you didn't make that graph. Okay, let's talk about the not equal to thing real quick. So let's say I had something like X is not equal to 3. Huh. So what could 3 be? I mean, what could X be? Any number besides 3. Could it be 2?
Yes.
Could it be 1.1?
Yes.
Could it be 3.1?
Yes.
Could it be negative 3?
Yes.
Could it be 0?
Yes.
Could it be 3.3?
Yes.
Could it be 3?
No.
Oh, I thought I would get some of you, like Simon says, but. So it can be any number besides 3. Any guesses how you graph that? Obviously, I'm going to have something at 3, right? 1, 2, 3. Go ahead. Ooh, very nice. And what would I put at the 3 itself, do you think? Good guess. It's still just going to be one of these two. What do you think? Would I put an open dot or a closed dot?
Close.
It can be anything except for 3. So can it be 3? No. I'm going to have an open circle at 3. And then Haley's right. I'm just going to shade both ways now. It can be anything else, bigger or smaller, doesn't matter. So that's how I would graph. X is not equal to whatever number. So actually, if you want to add that in your little list, not equal to would also be an open dot. Okay? This makes sense?